Daniel, that is going to talk about HPC opportunities in Europe, opportunities for research and fundings, I guess. Or...
As well, yes.
Perfect. Floor is yours. I think you have 30 minutes with questions.
Thank you for this introduction, and I'll let me try to keep this talk in time, taking into account the delay we already have. This talk will be very different, I presume, from what you've heard so far, because I'm working for a European funding authority. We support scientists working in the context of high-performance computing. And of course, this includes computational chemistry and related areas. And what I would like to present here is a bit, first of all, to raise a bit the awareness of these opportunities that these exist. We are a very new institution. We are still setting up our activities, our business, and also which opportunities already exist to participate and contribute to the European ecosystem. And with this, let me start with our mission. Our mission is a bit somewhat different from other funding bodies, such as the European Research Council that offers bottom-up research. So our approach is more top-down. That means we define challenges, of course, in collaboration with our stakeholders, with various groups of scientists, and also private partners, industrial partners, to design a coherent research and innovation program for Europe. So this is my kind of how I summarize this in one sentence: to develop a European high-performance computing ecosystem on the basis of as much European HPC technology as possible towards more strategic autonomy and digital sovereignty. So we have technology projects, we have software projects, and I'll say more about this. We have a number of institutions that participate. These are our so-called private and public partners that provide our funding. And these are 3 industry associations: the European Technology Platform for High-Performance Computing, the Big Data Value Association, and the European Quantum Industry Consortium. These are our private partners, these are our industrial partners that participate and advise us as we define our work program. And these are our public partners. Currently, we have more than 30 countries that are, we refer to them as participating states, countries that participate in our activities. And of course, the European Union, represented by the European Commission, is also one of our partners. So one of the reasons why we make this effort and spend significant amounts of money to develop European technology is the observation that we have in Europe a very successful, very active ecosystem of HPC users and applications, and Morecast is one of them, but there are of course many, many more applications in various scientific domains where you have a very strong position: application developers, application users. But what we don't have is European supercomputers, hardware, but also software stack, numerical libraries, and more. And this is what we are going to roughly to address. Now, for this, we receive a significant amount of money from the various actors. We receive funding from the Digital Europe program of the European Commission, from Horizon Europe, the Connecting Europe facility, and of course our participating states. So far we have about 1.5 billion euro in the last 2 years, and now with the new multi-annual financial framework, so the Union works in 7-year plans for the framework. We will spend another 7 billion euro on our research and innovation activities, but also on infrastructure. So for this, we offer a number of financial instruments that participants can apply for. These are traditional grants, such as grants also offered by national funding authorities, the open calls for proposals, and then consortia apply with their suggested work program. And we do this in a number of different areas. In the area of technology, for example, develop European processor technology, high-speed interconnects, and so on, but also applications. Tracks, one of the sponsors of this meeting, for example, is the European Centre of Excellence for HPC applications. This is also one of our programs here. Skills and use, and we'll hear certainly more about this in the Diana's presentation on the European Competence Centers for High Performance Computing. And the second big part is procurements. We own HPC infrastructure. And I don't want to spend too much time on this, so I'll tell you in another slide which systems are currently available and open to the European user community. Okay, here we go. So regarding the research and innovation activities, you can think of this in a number of, I call this intervention areas, where we address the challenges of the scientific and industrial communities in Europe. And if you think of it in different layers, we have at the very bottom the hardware layer, where we will launch in the near future significant activities towards European open hardware. So this will be based, for example, on new instruction set architectures such as RISC-V, but also we have the European Processor Initiative, just to give you an example, where we develop a European processor for high performance computing together also with our user communities, so to feed back knowledge from applications as far as possible. Then on top of this, you need an awful lot of system software to run HPC applications on this hardware. This includes programming models, tools for large HPC systems, exascale and post-exascale systems. And this will also be part of one of our upcoming initiatives. Now, perhaps the most interesting part for your communities are the top two parts of this diagram. This is application software, and here we speak about HPC applications as those addressed by the European Centers of Excellence for HPC application, but also we will fund the development of new algorithms that are exploiting the upcoming HPC architecture. So in think of an exascale supercomputer has a slightly different architecture. It will probably be somewhat a modular architecture compared to the last generations of HPC systems, and this requires specific programming models, new algorithms, other algorithms that need to be adapted to run efficiently on this large number of processes. And finally, leadership in using skills. So it doesn't help if we have very efficient hardware, efficient software and applications if the users, when they get an account on the HPC system, waste millions of CPU hours because they don't know how to run the applications properly. So this is one aspect that we address with, and here clearly our flagship project is the network of European competence centers, and you will hear more about this in another contribution to this workshop. So how to participate? And regarding our hardware development, I already mentioned, it is important, or it is considered as important when to get user feedback from application developers, from HPC users as early as possible in the development process of hardware. We call this co-design, where users, applications influence basically the hardware design by providing feedback in a feedback loop from the very beginning of the process. And so here we depend obviously on the contributions of the user communities. And for this, we have now launched a number of projects with experimental European hardware architecture, for example, with the European processor that we are developing for a few years already. This is a European pilot for exascale, for example, that will hopefully become available in the next 2 years. And here we offer an early access program for organizations that are not part of this grant, this consortium, to play basically with this new hardware and provide feedback to the developers. We also have a second pilot, the European pilot for exascale. This focuses on accelerators, and as you're well aware, modern HPC architectures are quite heterogeneous. They consist of using accelerators, GPUs, as well as CPUs. And the second pilot addresses those. Here we are developing a European accelerator chip on the basis of an open RISC-V instruction set architecture. This is run by Barcelona Supercomputing Center. We have presented a prototype of this chip. Now, what's perhaps particularly interesting for the quantum chemistry community is our activities on a quantum computing infrastructure. So we not only procure and own and operate HPC infrastructure, but we also have launched some activities already towards quantum computing. And we see quantum computing as part of HPC. So what you will see in the near future is supercomputers that include a quantum computer as a kind of module. You can think of this as an accelerator. As you do use CPUs and then you have a GPU accelerator, you may be able to use a quantum computer as an accelerator in the future. So you can potentially run some part of your algorithms on the quantum computer that are specifically well suited for this type of architecture, and then the rest on the traditional HPC system. So the very first project that we've launched in this regard is HPC-QS. Here, this is already ongoing, and we have just selected the supplier of this first quantum computer. We will buy 2 of these quantum computers. There will be installed one in Paris, in GENCI, computing center in Paris, and one in Jülich. And this will be what is called Fresnel analog quantum computers delivered by the French startup company Pascal. So these use neutral quantum computing architecture on the basis of neutral atoms and will offer more than 100 qubits. So this is expected to be something that is already useful for a number of applications, and we believe one of these applications could be quantum chemistry, specifically the correlation problem. So from our side, we will offer 50% of the available compute time on the systems to European users through an open call in a peer review process. So if you have heard about PRAISE ever, Partnership for Advanced Computing in Europe, so this will be very similar to the process implemented by PRAISE. Apply with an idea which kind of algorithm you would like to run on this computer or to develop. And then if it passes the peer review process, you get access to for free to these quantum computers. Beyond this, we have currently an open call for hosting entities for European quantum computer infrastructure. So this is basic. So as when we procure quantum computers, this is a 2-step process. So in the first open call, we select what we call hosting entities. So compute centers can apply, will be selected. And then in the second step, we do the procurement process. And we are currently at the point where we select the hosting entities that will host future European supercomputers. And we expect to buy at least 3 of them. We have a budget allocated of around 90 million euro in total, together with the participating states. And what we have the firm intention to achieve some diversity in architectures so that we can also support different communities, different types of applications. And here are some examples. So there are quantum computers now commercially available based on neutral atoms, but ions, for example, or also superconducting qubits. And they are developed in, for example, in Scandinavia mostly. And again, here we will provide 50% of the compute time through open calls to the European scientific community. And I can only invite everybody to, this will take some time, so it will not be available in the next 1 or 2 years, but it probably makes sense if you wish to consider using this to solve problems, for example, in quantum chemistry or whatever, to think a bit about how these computers may look like in the future, what needs to be implemented in order to use to run such applications. We also offer a number of other possibilities for participation. One example are the Centers of Excellence for HPC applications. We just closed a new call on those, on the next generation of Centers of Excellence, and we expect to announce the results, the selected consortia, in the next 2 weeks. So this will continue, and here we support. This is an initiative that fills a gap between science and fills to some extent a funding gap, because if you think about most of you are probably carrying out fundamental research. This is funded by specific national funding authorities, but they would probably not fund pure software development of applications. And this is what the Center of Excellence is, science-driven software development of HPC applications. So this is to modernize, to further develop, to improve HPC applications that will then be used on our European high-performance computing infrastructure. Another call that we currently have open, and also this may be interesting, is a call on new algorithms for European exascale supercomputers. This is, in terms of implementation, slightly different from our other calls. This is what we call a cascaded grant. So we will select a consortium of a few partners that get the grant. They get 5 million euro, and they have to spend 80% of this money in small grants to European scientists who work on the development of new algorithms for European exascale supercomputers. So we expect that the selected consortium will at some point launch a call, and this is really bottom-up research. So if you have a great idea about an algorithm but never had the time to implement this, or implement a prototype basically, then this may be interesting. The type of grants will be in the order of two full-time equivalent positions for 1 year to work on the first prototype of first implementation of a new algorithm. Now, I don't want to spend much time on this because this will be covered in another presentation. I just mentioned that one of our flagship projects, the European Competence Centers for High Performance Computing, very broad coverage. So in almost every country now such a national center exists that supports the local communities, but also in particular also the private sector, small and medium-sized enterprises, industrial actors, the public sector, and academia as well. And we will launch a new generation of this network very soon. So this will also continue in the future. We also run a number of other activities in the area of education and skills. One project that we've launched this year is the European Master Program in High Performance Computing. This is a pan-European master program delivering 120 ECTS education program by a consortium of it's a very large consortium. Lots of universities participate, also supercomputing centers and industrial partners participate. And there are a number of awarding universities where students can get their master's certificate from. So here in Sweden, it's KTH, in Stockholm, Erlangen, Germany, Luxembourg, University of Luxembourg, University Sorbonne, and others. And we are just about to complete the first selection round for the admission of the first cohort of students. So we start with a relatively small number, as it's still a bit of a pilot program. Students will also receive a scholarship to allow them the sufficient level of mobility that is expected in the program. So it is expected that students change after the first year from one country to another European country, and therefore we also provide financial support, of course, because as we are all aware, the living costs are very different in the different parts of Europe. So if you're interested, there's a webpage, and there will be also a next year we will again admit new students to this program. Now, a very different way to participate in our activities is more at the policy level. So if the communities are interested in this, so we plan to set up a user forum initiative in the near future to get the user communities more involved as we draft our new calls, as we identify scientific challenges that we believe should be funded with European money. And here we also, of course, to support a demand-oriented and user-driven HPC ecosystem. So this includes not only grants for research and innovation, but also, for example, how access is or will be provided to our supercomputers. Is this process, are there barriers too high, for example? Or is there something to be improved? Is too much data requested? Is the peer review process too complicated? So we need to improve this. And here we depend obviously on the feedback that we receive from the users. So, quick overview on our current high-performance computing infrastructure. So we have now a number of HPC systems all over Europe. I see there's a mistake. So the color should change. So the LUMI system in Finland is already available, so you can apply for compute time. Leonardo is unfortunately not yet available in Italy. And a number of smaller systems of the petascale range scattered all over Europe. Most of them are already available, and you can apply for compute time through our open calls. A little bit of an overview how much CPU hours are available every year. So Vega in Slovenia offers, for example, 138 million per year, and so on. Most of it is available on LUMI. LUMI was just listed as the third largest supercomputer in the world, and the top 500 list that has been announced last week. There's plenty of CPU time available. However, the architectures are occasionally different from perhaps what most communities are used to. So LUMI is an AMD system, for example. There are no NVIDIA GPUs, and it requires potentially a bit of different adaptation of the applications. These are, we launch regular calls 3 times a year with certain cutoff dates. So this follows very much the process implemented by Praise. And in fact, Praise is managing the process for us at this point in time. So there are many opportunities to apply for compute. Okay, so this is my last slide. So how to access our infrastructure. We have an access policy in place that defines all the different access models. We haven't implemented all of them, we're just working on this. But You find all relevant information in the internet. There is access is free of charge for research and innovation related to EU funding programs, or basically for the development of open modecasts. Certainly this falls in this category. It's a bit more different for industry, but it's not relevant maybe here. And we will probably implement at some point also access against payment. So you can pay and bypass the peer review process. Maybe it's not so interesting for academic communities, but for example, we also have to address industrial partners, industrial participants, and for them, money is not so much important, but if they need access, then they want it now and not go through a complex peer review process and allocate time for staff to work on the application. So with this, thank you very much, and I'm ready to answer the questions.
All right, thank you very much, Daniel. Questions? We have a few minutes for some questions. I see here we have a question from the chat from Pedro. Is the Chalmers quantum computer part of this project?
We so far not, but I mentioned that we are currently in the process to select new hosting entities and procure a significant number of quantum computers. And I wouldn't rule out that one of the quantum computers that we will procure in the near future will involve technology developed at Chalmers. But it will be a competitive process. We will select from the available European technologies in a fair competition. And if Chalmers succeeds, then we will have a quantum computer from Chalmers in the near future.
Well, I have a question. You mentioned quite a lot about quantum computing. Will there be also a part of training on how to use the quantum computer? I mean, I guess it's not just about press CMake and hope that everything works.
It will not be like this. And we are aware that currently most interfaces to quantum computers are like Jupyter worksheets. These are Python libraries. So we believe that this may not be the way how HPC applications are actually programmed, because they are still written in Fortran or C or some compiled language. So this will probably not work. This is one thing, and of course, an education on. So there are two components. First of all, the programming models need to be developed, and then users need to be educated in using these programming models. And this is work in progress. So but it's a very important point, and we certainly will address this in also maybe next year in a separate call, perhaps, or in a separate as part of one of our initiatives to get users ready for the use of quantum computers.
So there is let's say a roadwork for educating both.
Yes,
every level of academia or industry.
Absolutely. So the industrial partners speak about the value chain. So it's like all the different components, and all of them need to be addressed. Otherwise, if we fail, as I say, we can have the best hardware, but then if the users are not prepared, it's not going to create value. And very, very important point. And this will definitely be addressed.
Yes.
We did not disclose which quantum computers providers are going to be.
So,
information at the time, or
yes. So we have. So what I can already tell you is that this will be European quantum computing technology. So we will limit this to suppliers from, for example, to technology that has been developed as part of the Quantum Flagship project that is now going on for a while, but also through national initiatives, for example, in Europe. So that is one thing. The second thing is regarding the specific suppliers. We have now, for the first quantum computer, we have selected Pascal, or the consortium has selected this in an open tender procedure. And we do not at this point select the specific supplier. We have a list of European companies, of course. We know roughly the market, what is available, which technologies. The only thing that we ask now in our open call to define is the type of technology a specific hosting entity like computing center wishes to buy for their users. And then, of course, this limits the number of potential suppliers. If the hosting entity wants to have a quantum computer based on trapped ions, for example, then there may be only a few suppliers in Europe. And for superconducting qubits, perhaps even less, that have a product that is sufficiently mature, because we speak here not about developing quantum computers, we speak about operating quantum computers for the users. So there needs to be some reliability, and it cannot be offline for a long time.
All right, let's thank our speaker again.